Alright, so let's look at a couple more of these applications. From the top of the lighthouse, 175 feet above water level, you can see two buoys and a line. The angle of depression to the first is 13 degrees, and to the second is 9 degrees. How far apart are the buoys? So if you don't know what a buoy is, it's just something that floats in the water. It marks a position. Alright, so first we're going to draw a diagram. From the top of the lighthouse, 175 feet above water level. Alright, so here's our water level, and our lighthouse is 175 feet. We can see two buoys in a line, so let's mark those two buoys. There's one, and there's two. The angle of depression to the first is 13 degrees, so let's think of our horizontal. And so then my angle of depression to the first, oops, didn't draw that well. My angle of depression to the first is 13 degrees. My angle of depression to the second is 9 degrees. How far apart are the buoys? Alright, so now let's think a little bit about this. We have these triangles going on here, so how can we use those triangles? Let me sort of separate out one of these, part of this diagram. So we have this angle is 13 degrees. Alright, so if that angle is 13 degrees, that means that this angle must be, what, 77 degrees. And so then notice that this lower angle here must be 13 degrees. So we can use that fact. So if this angle up here is 13 degrees, this angle is 13 degrees down here. Similarly, using the same sort of process, we could say that this angle right here is 9 degrees. So I've got that lower triangle, I've got those lower triangles with the 9 and the 13 as well. And my thought is, well, I need to know the distance between the buoys, but if I also knew the distance from the lighthouse to the first buoy, let me call that y, I'm pretty sure that's going to be helpful. And in fact, that distance y is pretty easy to find. We can use a simple tangent ratio. So using that lower triangle, so the tangent of 13 degrees would equal 175 over y. So then, using a little bit of algebra, y would equal 175 over the tangent of 13 degrees. And so then y would equal 758 feet. Using a calculator for that. So now, if I look at that lower triangle, I'm going to outline now that lower one triangle here in red. Let's look at this red triangle now. That's outlined in red. I now know that y is now equal to 758 feet. And I can now use again a tangent argument with the 9-degree measure. So looking at the tangent of 9 degrees, I know that that would equal 175 over that distance. So now then this distance right here, the tangent of 9 degrees is 175 over 758 plus x, where x is that distance between the buoys. So then multiplying through by 758 plus x, so I have, what, 758 plus x times the tangent of 9 degrees is equal to 175. Let's divide through by tangent of 9 degrees. So 758 plus x is equal to 175 over the tangent of 9 degrees. And then I'll subtract the 758. So then x would equal 175 over tangent of 9 degrees, subtract 758. And so then x comes out to about 347 feet. All right, let's look at one more exercise. When the top of a mountain is viewed from a point 2,000 meters from the ground, the angle of depression to the top of the mountain is equal to 15 degrees. And when it is viewed from a point on the ground, the angle of elevation to the top of the mountain is equal to 10 degrees. If the 2 points are on the same vertical line, find the height of the mountain. All right, so we've got 2 points that are 2,000 meters apart. And we're looking at a mountain that's some distance away. And let's make some assumptions here that we've got some right angles. We know that when the top of the mountain is viewed from a point 2,000 meters from the ground, and we have an angle of depression to the top of the mountain, so we know that the mountain is less than 2,000 meters. We're above the height of the mountain. We're looking down at the mountain's top, and we know that my angle of depression to that is 15 degrees. But if I'm looking from this point that's on the ground level, we know that the angle of elevation to the top of the mountain, right, we know that this angle is 10 degrees. We wish to know the height of the mountain. All right, so in looking at this problem, it might be helpful as well to know the distance apart between these points, the horizontal distance between these points and the height of the mountain. So I'm going to call that horizontal distance apart x. And if I look at this triangle up here, if I think of the triangle, which I'll draw in blue, if I think about this triangle up here, it would also be a right triangle, and it would also have that same horizontal distance x. And this segment right here, this piece, I could say is the difference between 2,000 meters and the height of the mountain. So this distance right here must be 2,000 minus h. And so now what I can do is I can set up some equations. This one's a little different than the previous problems, but let's take a look at what we get here. So I can set up two equations that involve h and x. We can say that the tangent of 15 degrees must be equal to opposite over adjacent, 2,000 minus h over x. And we can also say, using the 10-degree angle, we can say that the tangent of 10 degrees is equal to h over x. And so we have simultaneous equations. We have a system of equations in terms of h and x that we need to solve. And so what I'm going to do here is I'm going to use a substitution. So since I want to, eventually I'm going to solve for h. I want to know the height of the mountain. So what I'm going to do here is I'm actually going to take these two equations and isolate the x. All right, so for the first equation, if the tangent of 15 degrees is 2,000 minus h over x, then x would equal 2,000 minus h over the tangent of 15 degrees. And if tangent of 10 degrees is equal to h over x, then x would also equal h over the tangent of 10 degrees. Now, if x is equal to 2000 minus h over tangent 15 degrees, and x is equal to h over tangent of 10 degrees, then I can set those two equations equal to each other. So then 2000 minus h over the tangent of 15 degrees would be equal to h over the tangent of 10 degrees. And now notice there's only one variable in this equation, and that is h, and we'll solve for h. To solve for h, I'm going to solve, basically now we have a proportion, so I'm going to solve this proportion. Or I'm going to rewrite it using cross products. So 2000 minus h times the tangent of 10 degrees would be equal to h times the tangent of 15 degrees. Distributive property on the left-hand side, we would have 2000 tangent 10 degrees minus h times the tangent of 10 degrees is equal to h times the tangent of 15 degrees. I'm going to move this term to the other side of the equation. So then I would have 2000 tangent 10 degrees is equal to h tangent 15 degrees plus h tangent 10 degrees. I can factor the h from the right-hand side. So 2000 tangent 10 degrees is equal to h times tangent 15 degrees plus tangent 10 degrees. And now I can solve for h by dividing through both sides of the equation by the quantity tangent 15 degrees plus tangent 10 degrees. So then h would equal 2000 tangent 10 degrees divided by the quantity tangent 15 degrees plus tangent 10 degrees. And when we calculate that value appropriately using our calculator, we get that that is about 794 meters. So the height of the mountain is about 794 meters. Alright, I hope these examples helped you out a little bit more on these types of exercises.